So we're starting section 5.5 today, we're dealing with law of sines. There's also a section that will start in a couple days called law of cosines. So we do have two different laws out here that we're going to use. They apply to different kinds of triangles. So law of sines is used for these three situations, all right? Angle, angle, sides, angle, side, angle, and side, side, angle. Do those look familiar from geometry? Okay. So you had an angle, angle, side congruence theorem. You had an angle, side, angle congruence theorem, right? This third one down here, side, side angle, is the one you didn't have. Side, side angle, if you're given two sides in the next angle, it does not guarantee congruence. Okay? That's called the ambiguous case. We're going to delve into that a lot today. What happens when you have those situations? Two sides in the next angle. And it really depends on how long are the sides, how big is the angle, to determine what kind of triangles you can make. All right, and then tomorrow we'll look at applying the law of sines to some real-world situations. So law of sines says if you have a triangle, and remember when we label things in geometry, we said capital letters were angles, lowercase letters were sides, and they're always opposite. So if this is angle A, side A is opposite it. Okay. It says, to find an angle, we can set up a proportion. The sine of angle A compared to side A has to be equivalent to the sine of angle B compared to side B, or the sine of angle C compared to side C. Now, all three ratios are given here, but you'll only be working with two at a time. So you might have the first two using A's and B's. You might be using only B's and C's, or you might be using only A's and C's. Okay? You're just going to have two of them. But you can compare any three sets. If we are trying to find the sides, it's easier to solve a proportion when your unknown is on top in the numerator. So remember from past math classes, proportions can be flipped, right? You can take the whole proportion and flip it, make its reciprocal, it's still equal. So if we are going to try to find the side lengths, I would set it up as side A is to the sine of angle A, as side B is to the sine of angle B, or side C is to this sine of angle C. Okay? So it's really the same law. It's just, are we looking for an angle or are we looking for a side? All right, that determines how you're going to set it up. All right, so our first case, we have two angles given. In this case, angle A and angle B are given, and we know side A. All right, they told us side A is 8. Given two angles and a side, only one triangle is formed. Okay, we don't have to worry about that ambiguous case. How would we find the missing pieces? Because it's asking us to solve triangle ABC. That means find anything that's not labeled. Any missing angles, any missing sides. We want to find it all. Do you have an angle and its opposite side where you know both of those values?
Yes.
Yes. We have angle A and side A right here. Okay. As long as you have a pair like that, you can use your law of sines and find your unknowns. We're going to set it up to find side B first, because I know angle B, I can use it to find side B. Okay, so side B is to the sine of angle B, in this case 48 degrees, and now I want to set that other one where I know the two values, the 8 and 36. Set it up in the same way. Side goes on top, so 8's going to go on top, and we need the sine of 36 degrees on the bottom. Okay? How do we then find B? Perfect. Multiply sine of 48 to the other side. So B is going to be 8 times the sine of 48 degrees. Make sure you close your parenthesis off after the 48 before you hit divide by sine of 36 degrees. All right, what do we get? Make sure your calculator is in degree mode, since we're entering degrees. All right, so we should get 10 point what? 115? Okay. Now, we have both A's and both B's. In other words, angle A, side A, angle B, side B. We don't know anything about angle C or side C. Can we find one of those? What would we find first? Are you finding angle C or side C? Angle. How do you find angle C? Exactly. Triangle angles add up to 180. So angle C would be 180 minus the two that were given, the 48 and the 36. What do we get for that? $96 degrees? Okay. Again, make sure you put degree symbols on those angles and that you label this with the angle measurement symbol, right? That angle symbol in front. So you distinguish its angle C versus side C. With A's and B's, you can tell capital letters from lowercase. With C's, it's harder to tell. Okay. Now, if we know angle C, can we use it to find side C? Okay. So side C is to the sine of angle C, which we found to be 96 degrees, as, and you can use your A's or your B's, right? I would start with A's, I guess, because that was a given one, in case you made a mistake on B's. 8 is to sine of 36. Okay, so C would equal 8 times the sine of 96 divided by the sine of 36. What do we get? Okay, so have we solved the triangle? We found all the missing angles and sides? Okay, so if you're given angle, angle, side, angle, you can set it up that way. Where we run into trouble is that side angle situation, okay? And we're going to take a few minutes to delve into what does that mean before we actually solve any equations or any triangles dealing with it. Do you remember from geometry when you did constructions, compass ruler constructions? Okay. With a side angle case, we are given two sides, like this side A and this side B, and then we're locked into this angle A. Okay? So picture angle A here being a fixed angle, all right? We can't make it bigger or smaller, it's locked. Side B is locked, all right? And because it creates part of this angle A, we can't really move side B at all. But picture your point of your compass being up here at letter C, and this side A is kind of like swinging on a hinge, okay? Because we don't know anything about angle C. That side A can swing back and forth to make angle C bigger or smaller, okay? So the situation is, how big is side A? Is it too short like this first picture? It doesn't even make a triangle. So if angle A is way too short, you're not going to get a triangle. If angle A, or side A, sorry, if side A is exactly the height of this triangle, in other words, it comes down from angle C up here and hits the base at a nice right angle, okay? We get one triangle, and we get a nice right triangle. If side A is longer than the height, when you think of that construction in geometry, this side, your compass point's here, your pencil point is here, and you can swing this back and forth like an arc, and it could hit here, or it could swing backwards and hit here. That creates two triangles. You have the bigger triangle, and you have the smaller triangle. Okay? So that's where it gets tricky, because you might end up with two different triangles. In our third picture, the length of A is bigger than B. How I know that is because I tried to swing this arc over here, and it missed the base. Okay? It's too long. It would go beyond side B. Okay? So here there's just one triangle. Side A is bigger than side B, and it locks it over here. Okay? As we go through these, I don't want you to get bogged down in, did they give me A? Did they give me B? Did they give me C? How they name it is not the critical piece. The critical piece is visualizing the given angle being locked. All right? You can't make it wider or smaller. And it's going to make it a lot easier if you set all of your triangles up the same way. So have that locked angle, that one that's set, always in this lower left corner of the triangle. Okay? The given side, you'll always be given a measurement for the side A, all right, the one opposite your locked angle, and you're always going to know the side in between those two. So basically, every single question you're going to go through, you're going to have a number for that, a number for that, and a number for that, regardless of whether they've labeled it A, B, or C. Okay? You're going to set it up in that position. It's going to make it much easier for you to visualize which of these situations you have. Okay. The pictures below here go into a little more detail. So we're going to look at each case. Notice now they gave me angle B. Okay, again, don't worry about the labeling, what it's called. They've locked in this angle, okay, and they've given me measurements for those two sides. Let's start with case 2 actually. Let's go back. Case 2 is the one where we get a nice right triangle, okay, which means this side B is really the height of the triangle. If I know this angle and these two sides, which trig function could I use with angle B? Which trig, like sine, cosine, tangent, which trig function could I use with angle B? Sine, because I know opposite and hypotenuse. So I could say the sine of B equals side B over side A. And if I were solving for B, I could multiply A over. So A times the sine of B equals B. Okay. And that's your height, which is what we have here. I just want to make sure you know why that's stated there, where it came from. Okay? It's coming from your SOHCAHTOA right triangle. So if side B is exactly the height, we get one nice triangle. If it's shorter than that, we have this first situation. It's too short, it doesn't make a triangle. You would just say no triangle exists, can't solve it. Okay. Case 3 is the one that it swings. Okay. So now the side B is bigger than the height, but smaller than side A. Okay. So it's somewhere, and you can kind of see it here. It's going to be in between the height length and side A. And it can swing in and it can swing out to get you the two triangles. The bottom two cases are just single triangles. If A and B are exactly the same length, you just get a nice isosceles triangle. If this side B is longer than side A, then you get one triangle. It swings to the right here, and it's too long to swing back to the left and make another one. Okay? So This is the case where angle A was acute. Okay, in all of these pictures we drew an acute angle. What does acute mean again? Yeah. So if your locked angle is smaller than 90, you really have 5 things to think through. Which of these pictures applies? Okay. If angle A or B, C, whatever the locked angle is obtuse, your options are much more limited. The only way you can make a triangle where your locked angle is obtuse is if this side B is bigger than side A. If it's exactly equal, it collapses and lands right on top of the other one, doesn't make a triangle. Because remember, this angle's locked. I can't change that. It's not long enough to come out here. And if it's much shorter, it doesn't even land on the first side. All right? It's just way too short. So for an obtuse locked angle, you really have only one option to get a triangle. And that's where the side opposite the biggest angle is bigger than that. And if you think back to all the stuff you know about triangles from geometry, right? The biggest angle has the biggest side opposite it. Yes? So if this angle is your biggest angle, which it has to be, it's obtuse, then this has to be your biggest side. Okay? So it's kind of summarized in this chart here, but again, rather than memorizing all those little, okay, A has to be bigger than B, but less than H, all of those different situations, try to visualize what picture you're looking at. Okay? All right, let's try a few. We're not going to solve them. We're just determining, does it make no triangle, one triangle, or two triangles? Okay? So remember, our locked angle is always going to go where? In my triangle. Where am I going to have my locked angle? Bottom left. Okay? We're going to set them all up that way. All right, for our first one, our locked angle is labeled angle B, 122 degrees, which means it's obtuse. Okay, so sketch roughly an angle of about 122 degrees. Okay. Side B, the one opposite that, is 3. So we have a side over here that's going to be 3, and the other given side here is a 4. Is everybody clear why I labeled the 3 and 4 the way I did? Side B has to go opposite angle B, right? Is that long enough to make a triangle? No. If your angle is obtuse, this side that's labeled a 3 would have to be bigger than a 4 to make it work. So this is going to be no triangle. We cannot do this one. For this part, yes, that's all you have to do. Okay, we're just trying to go through the different scenarios. Then we'll get to solving some. All right, next one. Given angle is C, it's 56 degrees. So sketch a 56-degree angle roughly. Label it C. And then look for side C. Side C is how big? 11.5. What's the other side that we're given? Okay, so this side here is 11, and this other side is 11.5. Is that long enough to make a triangle? As long as this opposite side here is bigger than the other side, it makes a triangle. Yes? It's when it's smaller that we have to worry about it. So we get one triangle here, and we'll be able to solve it very similar to the one the first example we did. Okay. Next one, we have a 36-degree angle. It's labeled A, so we're looking for side A to be opposite it, which in this case is a 7. And the other side we're given is a 12. Okay. Now our little 7 side is smaller than our 12. So now we have to decide, is it too small? Is it big enough to make a height and make that a right triangle? Is it bigger than the height so it can swing back and forth and make our 2 triangle situation? So anytime this side is smaller, like the 7 is smaller than the 12, you have to compare it to height. You're going to have to calculate the height. So h equals, do you remember the formula for it? Okay, and again, a sine b is assuming that this is angle B, right? We've called it angle A. So again, don't get bogged down by what letters they used. Think about the position. In this case, the sine of 36 is h over 12. So h would be 12 times the sine of 36. So it's always going to be this side here times the sine of this angle. That's your height. That's why I said always set them up with this orientation. It's going to make it easier. Okay, so h equals 12 times the sine of 36. Somebody punch that in their calculator. 7 point. Okay, so what does that mean? Is my little swinging side here, the 7, big enough to come down and make a height? No. If it's smaller than my height, there's no triangle that can be made, right? The shortest distance to a line is perpendicular here, straight line. Yes? And it's too small, so no triangle. All right. A 45-degree angle. Side opposite that is 6, and our other given side is 7. Since the 6 is smaller than the 7, we have to find the height. H equals what? 7 times the sine of 45? What do we get for that? Okay, so our height here is only about 5, right? A little under 5. So our side that's labeled a 6 can swing, okay? It can come out here, or it can swing back and come over here. Okay? So this is our 2 triangle situation. All right, at your tables, I want you to try E. All right, so in our example E here, angle C is 170 degrees. That's a really big angle. Yes? We have a side that's 39, and our side opposite, side C, is 52. Is that big enough to make a triangle? Yes. We get 1 triangle. All right, our last example, we're back to an acute angle, 55 degrees. The side opposite is how big? 3.8. And the other given side is 4.6. So what do we have to do? Find the height. Good. All right, h equals 4.6 times the sine of 55. 3.77? Okay, so is our 3.8 big enough? Barely, but it is, yes? So it's going to come down here, and that's our height. It would come down here or come in here. Yes? It's big enough for either of those. So we get 2 triangles out of that one. All right, so now we're actually going to start solving a few of these. Sometimes they will give you a picture, sometimes they will not. Again, if they don't give you the picture, make sure you set it up so your angle is the way we've described it, all right, in that bottom left corner. So, information we're given. We have an angle A of 26.3 degrees. The side opposite is 7, and our other given side is 6. So since the 7 is bigger than the 6, we can make a triangle, right? It's when that side is smaller that we have to worry about how does it compare to the height. So we have one triangle. We know angle A and side A, so we're going to keep those paired up in our ratio. And what other thing can we find? We could find angle B because we know side B, right? Okay, so we want to find angle B. We're going to say the sine of B compared to opposite side, which would be 6, equals the sine of 26.3 compared to its opposite side of 7. Okay, now, this is different than the last example we did because we're trying to find an angle. I can multiply the 6 over, but now I have the sine of B equaling whatever that decimal value comes out to be. How do I undo that? How do I find the angle if I know what the sine is supposed to be? Inverse sine, yep. So angle B, and I do want you guys to get in the habit of writing that angle symbol in front. Angle B is the inverse sine of 6 times the sine of 26.3 divided by 7. What do we get for the angle? Okay. Anybody else getting the same thing? Okay. Now what could we find? We've got the A stuff, we've got the B stuff. We could find angle C because we know all angles in a triangle add up to 180. All right. So angle C would be 180 minus the 2 that we already found, 26.3 and 22.32. What do we get? 131 point. Okay. Now what? Find side C. Yep. Okay, so C is to the sine of angle C. We found that to be 131.38. As, which pair should we use? A. Okay, so as 7 is to the sine of 26.3. Okay. Grab your calculators. 7 times the sine of 131.38 divided by the sine of 26.3. All right, 11.855. Okay, we good with that process? All right, let's look at one of our ambiguous cases here. The opposite side that we're given is smaller than the other side. When it's smaller, we have to find the height. So let's figure out the height for this one. So we have a triangle. Angle A is locked to be 30 degrees. Side A is 6, and our other given side is 7. What are we going to set up for height? Seven sine 30, yep. What is the sine of 30? 1/2. 7 times a half is 3.5. So is this long enough? Our 6 is bigger than our height, so it's long enough to make a triangle, but in this case it actually makes 2 because it's longer than that height. Okay, so it doesn't just come down here, it comes further out to the right. Okay, here, or it can swing back and hit here. We always want to start with the bigger triangle where this is acute. Okay, then we'll work on the case where that swings backwards to the left and our angle B here is obtuse. Okay, so we're going to start with that one. We'll come back to this one. Okay, we have an angle of 30 degrees and a side of 6. That's a nice pair for my law of sines. What else can I find? I could find angle B because I know side B. Now because we have two different triangles, I'm going to call this B1 and C1, okay, to distinguish, and on the other picture we'll have them be B2 and C2. Okay. So in my first picture, I want the sine of B sub 1 compared to opposite side of 7 equaling the sine of my given angle 30 degrees compared to its opposite side of 6. What do we do next? We will need to use inverse sine. Before we do that, we have to move the 7, multiply it over. Okay, so angle B will be the inverse sine. I'm going to move my 7 over times the sine of 30 divided by 6. Okay, grab your calculators. What do we get? $35.685. Okay. If I know angle B and angle A, can I find angle C? Okay, so let's do that next. Whoops. Angle C1 would be 180 minus the two angles that I know. One is 30 degrees and one is 35.685. Whoops, 114. Okay. What would it be to 3 decimals? Did you? 315? Okay. Let's go out to 3 decimals if you can. I know sometimes we can't do that. But if you can, let's try it. So we had 1/4. It's one of those days, right? It's not working. Okay, let's just redo it here. We'll start over. Okay, so B1 was 35.685. All right. C1 was 180 minus those, which was 114.315. Okay, thank you. Can we find side C? Okay. C is to the sine of 114.315 as what? 6 is to the sine of 30? Okay. So what do we get for C1? .936. Okay. So we have solved the first triangle. We now have to go back and look at the other option. Okay, this is called the ambiguous case. There's two things that can happen. When we compare the two triangles and look at that side swinging back and forth, our first triangle, we had it swing out here. Okay, in this triangle, we're having it swing back this way. What do we know about this blue triangle? It's what? It's isosceles. Why do we know it's isosceles? Right? This is 6, this is 6. Okay, and base angles are the same in an isosceles triangle. So if we found this angle to be, what was it, 35.685, then this is the same thing over here. Yes? Okay, so how are we going to find angle B2, the one I circled in red? Yeah, it forms a linear pair, right? Straight line. So if this angle here is 35.685, this has to be its supplement. Okay, so angle B2 is just 180 minus angle B1, 35.685, which gives us what? Okay, and if we know angles A and B, we can find angle C. So angle C2, 180 minus, what do we have? A 30 degree and a 144.315. Okay. And if we know angle C, we can find side C. C is to the sine of 5.685 as 6 is to the sine of 30. What? You took 180 minus 30 minus 144? You can't. Because 180, you're subtracting 174. 180 minus 174 would be about 6. Okay, that's right. Okay, side C2, what did we get? 1 point. Okay. So a little extra work when you have the two triangle situation, because you are expected to solve it both ways. Okay. Tomorrow we'll start out with that next ambiguous case one and do a couple application ones. And there's your assignment.